Welcome! In this lesson, we will compare denudation rates around the world. Denudation means the removal of rock and soil from Earth's surface by processes like weathering, rivers, glaciers, and landslides. We will use millimeters per year as our unit. Our goal is to build intuition for why some mountain belts erode extremely fast while others are comparatively slow, and then visualize the numbers side by side across timescales, short-term, millennial, and million-year scales. Before numbers, a quick qualitative tour of 4 key orogens. We'll show 3 timescales with colors: short-term in green, millennial in blue, and million-year in orange. Here are compact process sketches for 4 ranges: Himalayas, Andes, European Alps, and New Zealand's Southern Alps. The Himalayas, strong tectonic uplift and intense monsoon rain produce very high denudation. The Andes, rates vary strongly. Humid flanks erode faster, but hyper-arid sectors are extremely slow. The Alps, moderate rates today, with a strong imprint of quaternary glaciation. Southern Alps of New Zealand. Extreme rainfall plus rapid uplift make some of the fastest sustained erosion on Earth. Now, let's quantify with a side-by-side chart of ranges. Each row is an orogen. The horizontal axis is millimeters per year, from 0 on the left to 12 on the right. Each row shows 3 colored ranges: green for short-term, blue for millennial, and orange for million-year averages. Himalayas first, typical short-term 1 to 5, millennial about 0.5 to 3, and million-year 1 to 3. Note the hotspots at 5 to 10 plus in the syntax regions. The Andes shows strong climate control. Many basins around 0.1 to 0.6, with localized wet peaks around 1, and hyper-arid sectors down, near 0.01. The Alps are mostly 0.1 to about 1 today, with small glaciated headwaters occasionally reaching 2 to 3 millimeters per year. Long-term is around 0.3 to 0.8. New Zealand's Southern Alps are extreme on the wet west side, short-term 5 to 10, millennial 1 to 8, and million-year 5 to 7, with tiny glaciated catchments briefly exceeding 10. Let's crystallize the big ideas. First, the Himalayas and New Zealand's Southern Alps are consistently fast. They combine rapid uplift with strong rainfall, producing several millimeters per year. Second, the Andes and the Alps tend to be moderate on average, but both contain pockets of very slow or very fast erosion, depending on local climate and relief. Third, variability within a single range can rival global differences. Wet Patagonia versus hyper-arid Atacama differ by orders of magnitude. Finally, timescale matters. Recent and millennial rates often agree in active, wet mountains. Million-year averages can be lower where climate has varied, like in the Alps, reflecting quaternary accelerations. To wrap up, global denudation spans from less than 0.01 to beyond 10 millimeters per year. These comparisons come from multiple methods: basin sediment yields, beryllium-10 cosmogenic rates for millennial scales, and thermochronology for million-year exhumation. Together, they show how tectonics and climate set the pace of Earth's surface evolution.